Hello, and welcome back to Medical Physics 101, the series brought to you by Physical Sciences Consultorium in collaboration with Science for Everyone. I'm your host, Sajit Singh, and today, we're exploring how our bodies generate electrical signals and how we can use those signals to diagnose diseases. In this episode, we'll dive into electromyography, electrocardiography, and electroencephalography, more commonly known as EMG, ECG, and EEG, and how these technologies are crucial to modern medical diagnostics. Our body is constantly sending electrical signals, whether it's from our muscles, heart, or brain. But how do we measure these signals? This is where electromyography, electrocardiography, and electroencephalography come into play, or as we'll call them, EMG, ECG, and EEG. Electromyography, EMG, is used to measure the electrical activity in muscles, helping diagnose neuromuscular disorders. Electrocardiography, ECG, monitors the heart's electrical signals, allowing doctors to detect heart rhythm abnormalities and diseases. Electroencephalography, EEG, captures electrical signals from the brain, used primarily to diagnose epilepsy and sleep disorders. Now that we know what EMG, ECG, and EEG are, let's take a look at how they work. Each of these technologies involves placing electrodes on the skin to detect the body's electrical activity. For electromyography, electrodes focus on the muscles. Electrocardiography targets the heart, while electroencephalography focuses on the brain. When muscles contract, the heart beats, or the brain sends signals, electrical impulses are generated. These impulses are detected by electrodes, processed, and displayed as waves on a screen. Let's take a closer look at how these technologies are applied in medical diagnostics. Electrocardiography, ECG, is essential in cardiology for detecting abnormal heart rhythms, diagnosing heart attacks, and monitoring heart health. Electroencephalography, EEG, helps neurologists detect conditions like epilepsy, and it's also used in sleep studies and brain monitoring. Lastly, electromyography, EMG, is vital for diagnosing neuromuscular conditions like ALS or nerve damage, by measuring how well muscles respond to nerve signals. Behind each of these technologies lies the power of physics. The principles of electromagnetism allow us to capture and interpret the body's electrical signals. The precise measurements of voltage differences, as well as signal processing and filtering techniques, are all based on the laws of physics. Without physics, these advanced diagnostic tools wouldn't be as accurate and reliable as they are today. EMG, ECG, and EEG have transformed healthcare. They allow for real-time, non-invasive monitoring of our body's vital systems, which helps doctors make quicker, more accurate diagnoses. From emergency rooms to routine checkups, these tools play a critical role in modern medicine. As you can see, electromyography, electrocardiography, and electroencephalography are invaluable tools for understanding the electrical activity within our bodies. And this is just the beginning. There is so much more to explore. This series is brought to you by Physical Sciences Consultorium in collaboration with Science for Everyone. We encourage you to join us in this journey by liking, commenting, sharing, and subscribing to our channel. We also invite sponsors and collaborators to support this initiative and help make science education more accessible. If you or your organization would like to get involved, feel free to reach out to us. Thank you for joining us today as we explored the role of EMG, ECG, and EEG in medical diagnostics. Stay tuned for the next episode, where we'll continue to uncover the fascinating connections between physics and healthcare. Until then, stay curious, and don't forget to subscribe.